Hello guys, let's solve number of distinct islands today. This is a question that's frequently asked on TikTok. So we are given an m into n binary matrix filled with ones and zeros. An island is basically a group of ones that's connected four directionally. It means horizontally or vertically. We are required to return the number of distinct islands. So this is a pretty common question, but there is a catch here. We are asked to return the number of distinct islands. So, so they're saying that an island is considered to be the same as the another only if the island can be translated to the other island's position. So in this example, we have two islands here, but they are considered to be the same island because you can translate one to the another. And the second example, we see there are four islands here, but of these two islands are considered to be the same because you can translate one to the other. So you just return three. And with respect to the constraints, the rows and columns are within 1 to 50, which is not too high. So this is generally an indication that a recursive approach might be okay for it. So let's dive in.
Yeah, now we have the same example in here. So finding the number of islands is a pretty straightforward problem. All you need to do is just DFS starting from each point. So let's say we are starting from here and we see that it's a 1. So that marks the beginning of an island. So we start DFS from here. And then we slowly iterate to each cell of the island. And then once we cannot find any other one, that marks the end of this particular DFS, and that gives us one island. So at the end of the first DFS, we have one island, and then you continue over each cell and find the next one. And then once you find this particular one, you again start a DFS from here, and that is again going to give you another island. So at the end of this approach, you're going to have a list of islands and its corresponding coordinates. Now moving on to the tricky part. How do you exactly know that these islands are the same or distinct? So this can be solved in a pretty neat way. What we need to do is basically compute the relative positions of the islands. So let's take this island here. So we have 1 1 1 1. So let's compute the relative position of each of the cell compared to the top left. So let's mark the top left as 0 0, and then for this particular cell, the relative we can compute the relative position by the difference of the rows and the columns. So that's going to give us the difference of rows is 0, the difference of columns is 1, and similarly here the difference of the difference of rows is going to be 1 and the difference of columns is going to be 0. And then for this particular cell, the difference of rows and columns both are 1. Let's do the same thing for this particular island. uh, so this one, let's call the top left as always 0 0, and then we can compute the difference as 4 minus 3. The difference in columns is 4 minus 3, and the difference in rows is the same. So this is again going to be 0 comma 1, and then moving on to this cell, the difference of rows is going to be 3 minus 2 1 comma, and the difference of columns is going to be is going to be 0. So that's going to be 1 comma 0. And then repeating for the last column, last cell, the bottom right cell, we again get 1 comma 1. So we now see that how these two values are equivalent, and that's how we actually know that these two islands are actually one and the same. Moving on to the next example, um, uh, let's say we do a DFS, and that is going to give us four islands. These four islands, sorry, yeah, these four islands, and then we need to check each pair of islands and check if it's sort of the same or not. Repeating the same process for this island, we have the difference of uh, so let's keep this as the base, and the difference of columns is going to be 0 comma 1, 0 being the difference in rows and 1 being the difference in columns. And similarly for this particular cell, we are again going to get 0 comma 0 and 0 comma 1. Note that when I say the difference, the ordering matters as well. So if you are with respect to the base cell, that is the top left cell, make sure the order in which you take the difference actually is consistent when you do the comparison across different islands. Okay, well, let's dive into the code.
Okay, let's start coding. Um, let's initialize some variables. Let islands be the list which contains the final list of islands along with its coordinates. And I'm defining a visited array which is going to keep track of which particular cells I've already visited or not. I'm copying the entire grid for now. And then let's define the number of rows and columns as m and n. Then let's define the direction matrix, direction vectors. So let's say I stick with the same order of iteration. So I'm going to do right first, down next, left, and then up. And then let's say dn is going to be the change in columns. So right first, one, down next, left, and then up. Okay. Uh, and then let's start writing the code for DFS. Uh, so one more thing I thought I'll do is have something called an island ID. So this is just a way to know which particular cell belongs to which island, right? Um, so let's iterate over the entire matrix now. For I in range m, for j in range n. So if it's a 1, if you find a cell value to be 1 and it's something that you have not visited, uh, that marks the beginning of a new island. So notice how I'm using less than or equal to 1, so which basically means that since visited is a copy of grid, the initial value is going to be the same as the grid. So if the value is either 1 or 0, that means I have not visited yet. If it's a value higher than that, then that corresponds to this particular island ID that I'm constantly increasing whenever I find a new island, right? Uh, so this marks the beginning of a new island. So let's say that's an island, and then now I increase the island ID by 1, uh, and then I go ahead and append the first cell to this particular island. So that's going to be I comma j comma island ID, right? And I'm also going to mark visited with this particular island ID. So that the visited matrix not only gives me information as to what has been visited or not, but it also gives me the island ID corresponding for each particular cell. All right. Um, now let's start the DFS. So I'm gonna call initiate DFS with ij. Uh, I'm gonna pass in this particular island, and also I'm gonna pass in the island ID, right? Um, yeah. So now let's quickly uh, write the code for DFS. So DFS is going to be ij island ID. So now for the 4 possible directions, I am defining the new coordinate as I plus dm of k, and similarly I'm defining the new j coordinate as j plus dn of k. And then if this new cell is valid, so let me define this valid function later. So if this new cell is valid and if it has not been visited, new j is less than or equal to 1, then in that case what I do is I add it to the current island, and that I do by island dot append uh, new I comma new j comma island ID, right? And I also mark the visited array with this corresponding island ID, right? And then now it's time to recurse DFS um, new I, new J, and uh, island followed by the island ID. So now we're done with DFS. So now let's quickly define this is valid function. So that's basically just gonna do some boundary checks. So let's say it's I comma j. Uh, so if I is less than 0 or j is less than 0 or I is greater than or equal to m or j is greater than or equal to n, I return false. So these are all the boundary checks. And the other check is the cell must represent land, meaning it should not be water. So if it's water, you return 0 immediately. And finally, we return true. If both these conditions don't execute, we basically say that the cell is valid, right? So we are done with this. We're done with this. Uh, now let's go ahead and try to print out uh, islands and visited just to see if we have things working properly. Yeah, so we have to say islands dot append. So there seems to be a mistake in here. Um, oh, we need to do the appending after. Oh, I'm sorry. So this should be island dot append, and then finally you say islands dot append of island. So once you're done with the iteration, you basically need to append the island to the master list, which contains the list of all islands. Yeah, so now this looks fine. So you see how in the visited array, we now not only know what are all the different islands, but we have also given it a unique ID. And this list now contains a list of lists where each list represents an island. So this represents an island, and an island basically consists of uh, three valued tuples representing the um, row, column, and the corresponding island ID. So 0, 0, 0, 0, 2, 0, 1, 2, 1, 1, 2, 1, 0, 2. So that basically means this particular island, right? So now we have this list of islands, and we also have a unique ID for it. Now moving on to the tricky part where we need to sort of eliminate the duplicates, basically identify um, which islands are same and which islands are different. So now let's do that. All right, so I've just cleaned up the code a bit, and now let's try to find the duplicate islands. Uh, so let's say define number of islands as length of the islands. So now I'm gonna check every pair of island. So for I in range, and then for j in range, I plus 1 to num islands. So I guess this should be minus 1. Yeah. So now what we need to do is check if island I and island j are the same. Uh, so let's say we have a function called checksame where we pass in islands of I, islands of j. So if this is true, that means that the ith island and the jth island are equivalent. So we sort of don't want to count both of them. So how we can do that is one possible method is probably just change the ID of all cells in island j to that of the ID of island I, right? So let's grab the ID of island I as islands of I, and then let me just take the first cell of island I, and uh, and then now we have a tuple of three values representing the row, column, and the island ID. So the island ID is at index 2. So this is going to give the ID of island I. Now what I'm going to do is I'm just going to replace island J with a new island. So let's say this function is change ID. So it's going to take in the jth island and uh, assign all the cells this particular ID, right? Um, yep. So now islands now contains the list of the same islands, but wherever we found a duplicate pair, we basically change the corresponding ID to it, right? So now all we need to do is just count the number of unique IDs. So let's say unique IDs is a set, and then for each island in islands, what we do is basically uh, try to add the island ID. So I is an island. Um, so an island contains a list of tuples. So let's take the first cell because all the cells are going to have the same island ID, and now we have a three-valued tuple, and I'm going to take the value at index 2. So that is going to give the corresponding island ID. And then we can go ahead and return the length of unique IDs. Alright. So now we have these two functions to implement, check same and change ID. Alright. So let's first implement change ID. So change ID, basically what we're doing is we take in an island uh, and we also take in a new ID. What we need to do is basically return a new island with all the IDs changed, right? So for each cell in island, what we're going to do is just say new island dot append. We're going to append similarly a three-valued tuple, so it's going to have the same row, same column, but the ID is going to be changed to this particular new ID. Then I finally return the new island. So I'm doing this because in Python you cannot directly modify a tuple. If not, all I need to do is just directly change the value of tuple. But since in Python tuples are immutable, which means you can't directly modify it, I am just using a utility function that actually creates a new list, a fresh list, copies over all the values except for the along with the new ID, and then return it as a list. Right. So we're now done with this function, and then finally we need to implement the check same function. So this is the core of the core logic, I guess. So it takes two islands. Let's say we call it A and B, and this needs to return true if A and B are the same. Okay. So a simple boundary check is just computing the size of A and B, uh, and we know that if they are different, then that's definitely not the same. So we can immediately return false. And then now let's define the the top left point as the base point of reference. So I'm going to call it xa0 and ya0. So A is a list. A is an island. B is an island. So it contains a list of tuples. So A of 0 is going to give the first cell of the island, and A of 0 is going to give the x coordinate of that particular point. Similarly, this one is going to give the y coordinate of that particular point, and I'm doing the same thing for island B. Okay. Uh, Now I need to compute the relative positions and check if it's same for all other points, right? So that I can do as iterating over 1 to num of a. Since the 0th point is already the base point, for all the other points, what I'm doing is uh, checking the difference in the rows first, and then I do the difference in columns, right? So xi naught is a base x coordinate, and I'm checking if this particular difference in rows is same as the difference in rows of the island B, and at the same time I'm checking the difference in columns is same as the difference in columns of island B. Okay, so I'm doing a not because anytime I find if any of these is not equal, I immediately return false, right? So now if I reach a point outside the loop, that means that none of these cases were executed, which means all the relative positions were correct. That means that we have found two islands which are the same. Okay, so I return true here finally. So I think we have all we need. So let's check if this works with a sample case. Yes, it works. Yeah, not bad. 72%. So now let's see if we can actually do some optimizations. Yeah, so a very cool optimization that you can do here um, uh, is, is due to the fact that Python actually supports hashing tuples. So instead of maintaining islands as a list, what we can do is we can maintain it as a set. All right, and then what we don't need this island ID anymore. So um, let's just append the row and column, and since this is the first point, let's pass in 0 comma 0, because we know that the top left point is the base point of reference, and for everything, for every particular other cell, we're just going to compute the relative positions. So island is not going to contain all the coordinates anymore, but rather it's just going to contain um, information regarding the relative positions with respect to the top left point, right? So now what we do is we pass in, so these two arguments represent the base, the point of reference, which is the top left cell. So how we modify the DFS is I naught comma j naught. So let's say this is always the points to the top left cell of the currently searching island. And now again we don't need to append island ID anymore, and while recursing we pass I naught j naught. uh, yeah, and then finally island was a list before, but now it's a set. So now what we can do is we can say islands.add. So at the end of this DFS iteration, what we have is a uh, we have island. So island is a list of tuples with all the relative positions in it. So in Python, a very cool thing that you can do is you can hash tuples. So you can basically convert this list into a tuple by just calling tuple of island, and you can add this to the set. So this way, all the duplicates can be completely avoided. So at the end of this, all you need to do is just return the length of islands. So this entire part is not needed. Um, this change ID is not needed. The check same is not needed. So if you realize, this is internally being taken care by the hashing function. So when you add, um, since we are appending, oh yeah, so here we need to make a small change. So we need to append the difference in coordinates. So that's going to be I naught minus new I and j naught minus new j. So we are computing only the relative positions, right? So these things are internally being taken care of. So we can remove this as well, right? And yep, that should be it. We don't use this island anymore. Let's run it and see. It works, and this works as well. Surprisingly, this seems to be less faster. But anyhow, this is a pretty cool optimization because it saves a lot of code. You don't need to iterate over the list of islands again and check for pairs and see which ones are equivalent or not. So this set with the hashing function internally is going to do all the job for us in eliminating the duplicate islands. So that's it for today. Thank you so much for watching.